Okay, example 3, graph g of x equals 3/4 the x power. Now, I want you to, let me erase that because I'm not sure about my scale yet. If you're graphing just an x power on an exponential function, the three numbers you want to pick for x are -1, 0, and 1. Pick those three numbers. Those three are the easiest powers to evaluate. You don't even need a calculator to do this. A -1 power reciprocates. 0 power makes 1, first power makes the number. So if I'm doing 3/4 to the -1 power, that's 4/3. Because the -1 power is just a reciprocal. 4/3 as a decimal is 1.33. If I'm graphing a couple decimal places is sufficient. All right. Anything with the 0 power, 3/4 to the 0 power included is 1. And any number to the first power is just that number. So 3/4 to the first power is just 3/4. As a decimal is 0.75. For the sake of graphing, decimals are easier to graph than fractions. So we like decimals better than fractions when we're graphing. If I were to plot these 3 points only, and the numbers aren't ridiculously large or small, so I'm going to just go a 1-to-1 scale. So x is at a 1 scale and y is at a 1 scale. You know what? I might even go. Let's put y at a different. Let's go y at maybe a 0.5 scale. Because I got a lot of space there. I only have to go up to 1, right? Or 1.33. So 0.5, 1, 1.5. So it gives me a little bit more space to work with. On the test, several of you, I had scale established, and it wasn't you two specifically, it was the other class, but several people didn't pay attention to the scale on the graph. If I'm going to go to trouble giving you a scale, use the scale I give you. So what I'll do is I'll do that so that the points you would get out of the points you would pick end up on the picture, so it's easier to graph. -1, 1.33, 0.5, 1, 1.5 is here, 1.33 would be about 2/3 of the way between 1 and 1.5. 0, 1 is right here, and then 1, 0.75. We got 0.5 and 1. 0.75 is exactly halfway between. And those look like they almost make a straight line. Okay? X powers don't make straight lines, they make curves. One side flattens out, the other side goes up to infinity. And what you can see here is that this is the side going down to the right, and to the left is going up. Okay, so it's just a basic exponential function, that's how it's graphed. If you need more information, if you want to see how quickly it's bending up, all you have to do is pick some extra points. So if I would pick -2 and -3, because with my eyes I can see it's going up to the left, so I'm trying to get it up higher there. And at this point, I mean, I could do 16/9 and 64/27, but to get decimal approximations would be harder. So at this point I might go to my calculator, type in my 3/4. Now to type in 3/4 to the x power, I put parentheses, 3 divided by 4, in parentheses, caret x. And then I go to my table, I'm going to type in -2 and -3, just get some more numbers, 1.78 and 2.37. And again, just a general rule of graphing. If you can tell what the graph's supposed to look like with the dots you have, go ahead. If you can't, get some more dots. All right, so -2, 1.78. So we got 0.51, 1.52, so 1.78, which is just above halfway there. And -3, 0.51, 0.52, 2.5, 2.37, about there. You can start seeing the bend maybe occurring a little bit better now. If I go this way, if I pick a 2 and a 3, let's say, just to kind of get a better feel for how it's flattening out also. So type in 2 and 3, we get 0.56 and 0.42. Okay, so 2.56, which would be just above 0.5, and 3.42, which should be just below 0.5. You can kind of see it's flattening out there. What happens is, if you consider, here's 1 right here where the red dot is, right? Once it crosses that 1, it's not going to get past the next number down, is what happens. So it's going to flatten out at 0, because no matter how big I make x to whatever power, 3/4 of that power will never be negative. It'll never equal 0, so it's going to stay above 0. So there's my dots, and I just connect them with a nice smooth curve. Almost a smooth curve. I'll try again. smooth up until I got to about right there. That's better. So it's going to level out that way, and it's kind of going up this way, so I'll make it go up that way. On exponential graphs, the things I look for when I'm grading, I want to see a bend, so give me enough of the curve so I can see the bend. I also want to see that it flattens out. I see too many people just like, they'll just get those points there and they'll just do something like that, not even trying very hard. So give me enough points so I can see the bend and I can see where it flattens out. I can see that you understand that there's a leveling out process on this. If you need to know what it levels out at, it's real simple. Pick a big number. 0. All right, that's 3 e negative 63. That's 0.620 It's almost 0. All right, so if you need to know what it levels out at, just whichever direction it's going, put in a big number that way. That's what it levels out at. All right. If it was y equals that plus 1, just to show you. Plus 1 should just move the graph up 1, right? So now it should level off at 1. Go to our table, 1. All right, and that's what you don't want to cross is that level. It's kind of like a horizontal asymptote idea. All right? And that's all graphing an exponential function is going to be, a basic one like that, just number raised to the x power.